continue solving our task, and today we have the following screen. And let's go to our neetcode. Let's go here, and we have 2 pointers and trap and rainwater. So it's hard task, and it's a hard task for 2 pointers. So let's read first the task definition, and let's check. So we're given an n non-negative integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap after raining. So we have an array with bar widths. So it's like bar heights, and our task is to return how many water we can trap water. Okay, so let's write some examples. So for example, if we have 0, and let's start. Let's define some constraints. So let's say that it's greater or equal to 1, and let's say that it's like 10 in 5 power. It's quite a big one. And also let's say that our values is positive integer plus 0. And let's run some test cases. So we have, for example, 3 zeros, so it means we cannot trap any water. Also, if we have, for example, something like 0, 1, 0, we also don't have anything because it's not trap. So we have trap only between some boundaries greater than 0. So for example, if we have 1 and 1, we also cannot trap here, so we need like I and J somewhere in between. But 1, 0, and 1, then we can trap 1. Yes, we can calculate the left and right boundaries and also multiply this by I minus J. So in this case, it would be 0, 1, and 2. So 1 minus 1 and minus 1, because we need, so it would be 1. Okay, but what if we, for example, have a combination of such traps, right? For example, here, then we have something here. Yeah, I think we can take this example. And from this example, we see that it's 6, because it's like 1, 2, 3, 4, 5, and 6. So it's 6 values. So how to approach this problem? We know that we need to use some 2 pointers here. And if we will put these 2 pointers right over here, we can see that this one is 0. So we cannot actually drop anything from here. So I believe when we, for example, on 1 and 1, it's like on the same level. So it means all. So yeah, it doesn't matter that it can be trapped, because, for example, we can have something like this, and here it would be 0. So it doesn't work this way. So we do not know when we own the borders, and somewhere in here, we don't know whether it would be, it would be trap or not. So what we can do other way? Other way, we can start, for example, from the beginning and go. So we have 0 and 1. And then we know that if if the next value is greater than 0, than the previous one, we should actually calculate. And then we should, like, when we calculate, we know already this trap, so we move until this one, and then we go forward until we will reach equal or greater. So when we reach greater, we calculate, and then again move forward, and we calculate. Actually, why will we move this value forward? We calculate, and then once again we move until we reach 3. So we reach 3. But when we reach 3, we know that all this water would be covered. So with which level? With level 2. But with level 2, not all of them would be covered. So we should iterate. Yeah, maybe we can add this value, right? And then we can iterate and decrement the size that we add here, right? So we go here and we decrement 1. Then here we don't decrement, and then we again decrement 1. Yeah. And then when we reach 3, unfortunately we don't have anything other, so we cannot calculate. But then we can move, I believe, from the right to the left, and once again calculate these values. And once again calculate these values. But also I think we should not calculate them twice. So let's have kind of a set of visited. So set of visited, it would be like combination of index I and j. And if we already visited, we should not calculate. And then we should go from the both directions, from left to right and from right to left, and do this calculation. So the calculation would be following. So we start with 0 and 1, and if 1 is greater than or equal to the previous, we add to our result, and then while we move this pointer, we decrement this result, right? So let's have result 0, then we have set of visited indexes, and then we iterate first from the beginning to the end. So from the beginning, actually, we don't have visited, so we actually can just skip them, and we can calculate we can calculate these values. So here we have I, and also we have we have I that is and j is 0. And here we check if height on I is greater or equals to height on j. We do the following. We should add to result or the minimum of these both heights. Yeah, and I think that if I minus j and I think, yeah, it doesn't matter. So we can just add the minimum of these both results. And then we multiply by I minus j minus 1. Yeah. And then while j not equal to I, we actually move and we decrease our result if yeah, height j, we can do like j plus 1 and decrease our result by height j. And also we should add visited and new I and j. And yeah, so here it would be the first iteration. And in the next iteration, we should start from j, it would be height length minus 2, height length minus 1, and I, it would be height length minus 2, I greater or equal to 0, and I minus minus. And here we have the following. So if yeah, I think the same. If it's equal and if visited contains, not contains, here it would be I and j. I and j. Then we can do this operation. I, j, here I think it should be j minus I. And then yeah, with it doesn't matter, so then we should iterate j minus 1, and here we do the same, but j minus minus, here j plus plus. And yeah, and then we return results. So yeah, actually 2 loops from both sides, and here we do not calculate anything, right? Yeah. Yeah, let's start. N. Okay, let's run. Output is 4. Expected to. Okay, so let's use this test case and let's run what we have here. So we have 2 and 2, right? So we first start here. And yeah, and visited is empty. Then we have I. Here we don't have height. Height is not greater than J, so we move forward. But here's become greater. So we increment our height by minimum 2, multiply by 1, so it would be 2. Then I put visited, I and J. Okay, so I think that here it should be J and I. Let's run. No? Okay. If height okay. So yeah, so here's first should be 2. Then we put visited as 0 and 2. Then we increment our J by 1. And yeah, so result height, so -0. And then it's going here. Then we start from the end. And here too. Okay. So here we are not going, but then if we go here, we should take I. It should be 0. And J should be 2. And if it contains, but yeah. So I don't understand why we go here. So let's print visited, right? Then let's print result. And also let's print ing. Let's run. Okay, so no 0 and 2. So result here is 2. Here is 0 and 2. I don't understand why we. So when we print visited, so Okay, print dash set to wait, I don't understand, like, why its print so different? Maybe this one doesn't work. Here we should have some string, and here we should do like I plus this one, and here it should be the same. This one. Okay, understood. Okay, understood. I understood why it's printed like this, because we have we have inside. Yeah. So yeah. So here we should do like j plus I. Yeah. Okay. Once again. Once again, we have duplication. False. 0550 10 okay, and 57 here as well. Yeah, I think that some combination doesn't work here. Okay, 07. So we have 05 and then 5 7. Okay, but here, if visited contains, here we still need to do yeah, so if they contains, we still need to move our j to I, but without anything. Yeah. Let's remove the system out. Let's run. Okay, that's it. Yeah, so we're done. Hard task actually. And let's check our submission. All right. So we was with 1 millisecond, now 15. Oh, okay, so here we don't have set. I think it's because of this set, right? Thinking because of this set. So left and right, max left, max right, result. Step-by-step algorithm. Gonna change. It looks like the logic should be the same. Yeah, I'm just curious about this visited. Okay, yep, so I think that's it for today. 27 minutes. So we can mark it as done. So it's hard task. So we go tomorrow, I think, with stack task. So I believe tomorrow we will be able to solve these 4 easy tasks. And then we can go to somewhere here. All right.